Welcome to video number 84, 16 away from the big 100.
Yep,
It's going to happen.
it will.
All right. We're going to talk about
Inevitably.
calculating confidence intervals.
Yes, we are.
All right. So we want to get very familiar with this formula.
Yes.
So this formula has three parts.
Uh-huh.
First part is p hat,
P
which
hat.
is
P hat is your sampling proportion.
right. Okay. Then this is a z star. The z is actually an asterisk, or maybe put an asterisk up there.
Put up a little
When we made our
asterisk.
confidence intervals in class, we did some multiple of standard deviations.
Yes.
Like the first intervals, we added and subtracted one standard deviation. And then the second round, we added and subtracted 1.645 standard deviations.
Mm-hmm.
The last one, 2 standard deviations. This z star is the number of standard deviations we're adding and subtracting.
Right.
All right, so that's going to be a number we give you. 1.645 will give us a 90% confidence interval.
Mm-hmm.
All right, so that's a number that will be supplied to you. How many standard deviations? This SE business, Mr. Lewis, what the heck is SE?
Well, SE, since we don't know what our true proportion is, because
Right.
we're using the sample to estimate it, we therefore don't know our true sigma, or our standard deviation. So the SE is what's called the standard error, and it's
Yeah.
calculated using our P hat and Q hat.
It's an approximation of the standard deviation.
Right.
Could you do me a favor over here? We're going to write the two formulas. So over here, down here, before we get to our problem, write sigma p hat.
Sigma
P hat.
P hat.
P hat is a subscript.
Oh.
That means the standard deviation of
Got
p
it.
hat equals, we're going to write the formula, square root of p times q over n. That's what we've been using.
Yes.
The problem is, now we're getting to the situation which is realistic. We don't know p or q.
Right.
If we knew that, we wouldn't do any of this.
Yeah,
So
that
we
would
have
be
to
nice.
estimate them. So the standard error, we're going to write the formula for the standard error. What we're going to use is p hat instead of p, our approximation. So the big difference is between standard deviation and standard error. The standard error is an approximation
Mm-hmm.
using the sample proportion, not the real proportion.
Yes.
Okay, so that's what standard is. So here we got our p hat plus or minus some number of standard deviations.
Correct.
Okay, here it is.
Okay, so we have teenage drivers, just like all of you. An insurance company checks police records on 582 accidents and notes that teenagers were at the wheel 91 times.
All right.
So, we want to compute a 95% confidence interval for the percentage of all auto accidents, in the country that involve teenage drivers. So first we need to figure out what our p hat is. So that would be 91 out of 582, which Mr. Miller is
0.16.
0.16. So
Okay.
our sampling proportion is 16%.
Can you put a hat over that p?
There is a little hat. It's just smooshed.
All right, cool.
It's like a hat on a hat.
Because I want to emphasize that's all we got is the sample proportion.
Yes.
All right, and our goal is to compute an interval which hopefully contains the true proportion.
So we're going to need our SE. So if we know P hat, Q hat would have to be 0.84. Okay, and our N would have to be 582. That's our sample of accidents.
So it's kind of the same what we
Okay.
did before, but we're using p hat instead of p.
Right. So
And it's an estimation.
0.16 times 0.84, all divided by 582, and we take the square root of all that jazz.
You get 28 there. So
Oops.
582.
All right. See, I'm dyslexic today.
That's all right.
Okay.
Equals 0.015. Okay, now this is going to go quick. We wanted a 95% confidence interval.
Mhm.
So I believe we need z star equal to
1.96.
Yeah.
So it would be 0.16 plus or minus. So we're doing it twice because we want a lower and an upper bound.
Yeah, so that's p hat plus or minus.
1.96.
That's how many standard deviations we want to go.
0.015.
And that's our approximation of the standard deviation.
Yep.
So it's kind of like what we're doing in the Cubs trial. adding or subtracting some number of standard deviations.
Right.
Except this is an estimate for the standard deviation.
So what is
Alright.
our lower bound?
Oh, I'm supposed to be doing that? Times
You probably, yeah. You probably should be doing
0.16
something.
minus 1.96 times 0.015. The lower limit is 0.13.
Okay. 0.13.
And
our
the
upper limit.
Go back and just make that a plus. Is 0.19.
0.19.
So that's our interval. Our interval says between 13% and 19%.
Right, because now we can interpret it.
Yeah. Now this is important, how to explain the interval. It's going to kind of follow the same pattern. We are 95% confident. It's a 95% confidence interval.
Yeah, so that makes sense.
The interval and we'll write the interval. So it's
0.13. Oops, that was meant to be a parenthesis.
To
0.19
contains the true proportion. Now we have to state it in context.
The true proportion.
Sorry about this. Of accidents with teenage drivers. I'll come back in a few minutes. It's all hard to write with that.
Yeah.
But this is
it's
kind of
harder
a
as
pattern. So this is an explanation of what the interval means. Remember, the interval is random. So if we take another sample, we get a different interval. The point is, 95% of the time we do this process, it'll contain the true value. We don't know if the true value is in between 0.13 and 0.19. You'll never know. But we know that 95% of the time we do this, it'll contain the true value.
Yes.
So that's the idea of level of confidence.
Mm-hmm.
All right, so that's pretty confident.
Yeah.
95% of the time is pretty good.
Yeah, I mean, you're never going to be 100% confident.
Well, if you say that the true value is in between 0 and 100.
Well, I guess, yes. I don't see us getting employed doing that.
No. All right.
So
we want to talk a little bit about some terminology. So we already mentioned SE. So maybe we can write above it. SE stands for standard error. Or below it. And that's just an approximation of the standard deviation.
Right.
Why? Because we don't have enough to compute the true standard deviation.
So approximate sigma.
Yeah. Okay. If you multiply Z star times SE, that part that we're adding and subtracting is called the margin of error.
Margin of error.
Now, I want to go back to the problem we just did. Not screen-wise. Could you write 0.16? That was our value of p hat. And what we did is we did plus or minus 0.03. That's what we ended up adding and subtracting when I did it. So what we could say is our estimate is 16% plus or minus 3%.
Yes.
So in this problem, 3% is the margin of error. And you see that in the news when they're like polling for president.
Yeah.
They'll say like 46% support Obama with margin of error 2% or something like that. That's what they're talking about. They're giving us a confidence interval.
All right.
Okay. Forward.
Forward. I like going forward.
All right.
Okay. Direct mail advertisers send solicitations or junk mail to thousands of potential customers in the hope that some will buy the company's product. The response rate is usually quite low.
Yeah, throw those away.
Suppose a company wants to test the response to a new flyer and it sends it to 1,000 random people.
Wait, I don't want to interrupt. I'm going to throw that one away too.
From their mailing list of over 200,000 people. They get orders from 123 of the recipients. Okay, so we want a 90% confidence interval of how many people would be.
So they sent it to us. Okay.
Right, they sent it to us. So yeah.
Could you write the formula?
So p hat is plus or minus z star times se.
You're going to get familiar with this formula very quickly. All right, so you do it a couple times.
So our p hat is 123 out of 1,000.
0.123.
Right.
12.3%.
Okay,
Plus or minus.
plus or minus. So we want 90% confidence.
In class, when we did this, that worked when we did z star equals 1.645.
Yes.
That's like the magic number to make it work out to 90%.
Mm-hmm.
Then maybe down here we can figure out the standard error. We can put it in.
Actually, I'll do it up here.